All right, get ready, because today we're going deep on parathyroid hormone.
PTH.
Yeah, PTH. This tiny but super important hormone that basically controls how our bodies deal with calcium.
Right, and it affects so many things.
Yeah, it's a big deal for keeping our bones strong and our nerves firing, right? Even making sure our muscles can contract.
Exactly. And what's really interesting about PTH is that measuring it accurately is actually pretty complex.
Oh, why is that?
Well, for one thing, PTH has a really short lifespan.
Short. How short are we talking?
We're talking just a few minutes before it breaks down into fragments in the bloodstream.
Wow, so it's in and out of there super fast.
Yeah, it is. And get this, some of those fragments, they might actually do the opposite of the full hormone when it comes to calcium levels.
Oh, hold on. Opposite. So like some raise calcium and some lower it.
And that's just one of the things that makes PTH so fascinating.
So how do we even measure this thing if it's breaking apart and doing all these different things?
Well, that's what we're going to unpack in this deep dive.
Okay, I'm ready to unpack.
We'll look at how PTH tests have evolved over time, try to solve the mysteries of those fragments.
Sounds like a detective story almost.
It kind of is, and we'll see how all of this knowledge is used to diagnose different conditions.
I'm sure there are a lot of them, given how important calcium is.
There are, and you might be surprised by how much those tiny fragments could be influencing your health.
Okay, I'm intrigued. Let's start with the basics then. Remind me again what PTH actually does in our bodies.
Okay, so think of calcium like a vital building block.
Okay, building block.
Yeah, for your whole body. It's
Yeah.
essential for so many things.
Yeah, like you said, bones, nerves, muscles.
Exactly. And even blood clotting.
Oh, right, I forgot about that one.
So if your calcium levels get out of whack,
Things can go wrong pretty quickly.
you got it, and that's where PTH comes in.
It's like the manager keeping everything running smoothly.
Yeah, like a master regulator constantly monitoring and adjusting those calcium levels in your blood.
So if it senses calcium is dipping too low,
Then your parathyroid glands.
these are those tiny glands in your neck, right?
Right, they release PTH.
And that PTH acts like a messenger.
Exactly. It tells your bones to release some stored calcium.
Oh, wow. So it's going straight to the source.
It also tells your kidneys to hold on to calcium instead of flushing it out.
Makes sense. Conserve what you've got.
Right, and it even tells your intestines to absorb more calcium from the food you eat.
Wow. So it's coordinating this whole effort to get those levels back up.
Exactly. It's pretty amazing how our bodies just do this automatically.
It is. It's like one of those fancy thermostats that keep adjusting to maintain the perfect temperature.
That's a great analogy. And remember, we said PTH has a really short half-life.
Yeah, you said just a few minutes. It's hard to imagine it disappears that quickly.
It does. It's constantly being produced and broken down.
So like a rapid turnover.
Yeah, very rapid, which means the levels we measure are really just a snapshot.
A snapshot in time.
Right, of this constant process. And to make things even more complex, most of the PTH in our blood isn't even the full active form.
It's those fragments again.
Yep, mostly fragments.
So it's like we're measuring pieces of a puzzle instead of the complete picture.
You could say that.
And that's where things start to get tricky, right?
Definitely, especially when you consider that those fragments might have different effects.
Like we were talking about before, some raising calcium, some maybe doing the opposite.
Exactly, and that's where the story of PTH testing gets really interesting.
Okay, lay it on me.
So in the early days, scientists used tests called radioimmunoassays.
Radioimmunoassays, or RIAs. I've seen that in some older research papers.
Right, and those weren't very precise. They mainly detected the inactive PTH fragments.
Oh, so it was hard to know how much of the full PTH was actually working?
Exactly, and that's a problem because you need to know the active amount to really understand what's going on.
So it's like trying to understand a book by only reading a few random sentences.
Yeah, you'd miss a lot of the story.
So what did they do? How did they improve the tests?
Well, thankfully, science marched on.
As it tends to do.
And we got something much better. Immunometric assays, or IMAs.
IMAs, okay. Those are the ones used today, right?
They are, and they were a big breakthrough.
I'm guessing they're much more accurate.
You bet.
So tell me, how do these IMAs work? What makes them so special?
Well, imagine you have two magnets grabbing onto a piece of metal.
Okay, I can picture that.
That's kind of how these newer tests work. They use special molecules called antibodies to grab onto PTH.
Antibodies, those are like the body's natural defenders, right?
Yep, but in this case, we're using them to latch onto and measure PTH very precisely.
Clever. So how do they actually grab onto it?
Well, one antibody grabs onto one end of the PTH molecule, and the other antibody, which has a special marker on it, grabs onto the other end.
So it's like they're trapping the PTH between them.
It's like making a PTH sandwich.
A molecular sandwich. That's a great way to visualize it.
And this sandwich approach, it leads to much greater sensitivity and specificity.
So we can be more confident that we're measuring the right thing.
Exactly, and that's had a huge impact on how we diagnose and manage all sorts of conditions related to PTH.
This is already so interesting, and we've only just scratched the surface.
I know, right? And there's so much more to uncover.
I'm all ears. Give me the next layer of this PTH puzzle.
Okay, so even within IMAs, there are different generations of tests.
Different generations. So they've gotten even better over time.
They have. The first ones were called intact PTH assays.
Intact. So they measure the whole PTH molecule.
Well, they measure both the full active PTH and some of those larger inactive fragments, too.
Ah, I see. So there's still some room for improvement there.
There is, and that's where the bioactive PTH assays come in.
Bioactive. Okay, so those are even more specific.
Exactly. They're designed to zero in on just the fully active PTH.
The one that's actually doing the work of regulating calcium.
That's the one.
This is getting really fascinating. So the bioactive assay seems like it would be the gold standard then.
Well, you'd think so, but here's the thing.
Okay, what's the catch?
Even the bioactive assay picks up this mysterious fragment called NPTH.
NPTH, another fragment. So even our best tests can't completely separate them all out.
That's right, and to make it even more interesting,
There's more.
there's another abundant fragment called PTH784.
PTH784. Okay, I'm starting to see why you called this a puzzle.
It really is, and this is where things get especially fascinating.
Okay, I'm on the edge of my seat.
Because while the full PTH molecule, PTH184, raises calcium levels,
Right, that's its main job.
PTH784 might actually lower them.
Wait, what? So a PTH fragment that lowers calcium? That doesn't make sense.
I know, it seems counterintuitive, right?
Totally. Why would our bodies make something that goes against what the main hormone is trying to do?
That's a great question, and it's something scientists are still trying to figure out.
So there's still a lot we don't know about these fragments.
Oh, absolutely. We're just starting to understand their roles.
So why should we care about these fragments? How do they impact our health?
Well, if you think about it, this interplay between different PTH fragments, it could really affect how our bodies respond to the hormone overall.
That makes sense. It's like having different chefs adding ingredients to a dish. The final flavor depends on what everyone contributes.
Exactly. And this could have implications for things like bone health and overall calcium balance in ways we don't fully understand yet.
Wow, so it's not just about these tiny fragments. It's about the bigger picture of how they all work together.
You got it. And this isn't just abstract science either. It could have real implications for your health.
This is mind-blowing. I'm starting to realize how much more there is to PTH than I ever imagined.
It's a fascinating area of research, that's for sure.
I'm hooked. It sounds like these fragments could really be shaking things up when it comes to understanding PTH and how it impacts our health.
They really could be. And that's just the tip of the iceberg. Are you ready to dive deeper?
Absolutely. Lead the way. Let's explore how this all plays out in real-world medical scenarios. All right, so we've talked about the basics of PTH and all those fascinating fragments.
Yeah, those fragments are really shaking things up.
They really are. So let's see how this all plays out in the real world. How do doctors actually use these PTH tests to diagnose different conditions?
That's a great question. And there are actually quite a few conditions where PTH testing is crucial.
I can imagine, given how important calcium is for so many bodily functions.
Exactly. One of the most common applications is in diagnosing primary hyperparathyroidism.
Okay, primary hyperparathyroidism. Can you break that down for us?
Sure. Basically, it's when one or more of your parathyroid glands, those tiny glands in your neck,
Yeah, the ones that release PTH.
right, they become overactive and start producing way too much PTH.
So it's like they're stuck on the on switch,
Yeah, exactly. And all that extra PTH leads to high calcium levels in the blood.
which is called hypercalcemia, right?
And hypercalcemia can cause all sorts of problems.
Yeah, I remember reading about that. Kidney stones, bone weakening, even cognitive issues.
Right. It can really impact a person's life.
So diagnosing primary hyperparathyroidism accurately is super important.
It is. And thankfully, both the intact and bioactive PTH assays are pretty good at doing that.
So they help confirm whether those parathyroid glands are the culprits behind those high calcium levels.
Exactly. And you mentioned earlier that bioactive assays might be even more sensitive in some cases.
Yeah, is that right?
It is. There is some evidence suggesting that bioactive assays could be especially useful when someone has very mild primary hyperparathyroidism.
So like in the early stages.
Exactly. The intact assay might still show PTH levels that are within the normal range.
So it wouldn't raise any red flags.
Right. But the bioactive assay, because it's zeroing in on just the active PTH, might pick up on a slight elevation.
So it's like having a more powerful microscope.
That's a great way to put it. It could help us catch those borderline cases earlier before they develop serious complications.
That makes a lot of sense. Early detection is always key.
It is. Now, another important use of PTH testing is during surgery to remove a parathyroid adenoma.
An adenoma, is that like a tumor on the parathyroid gland?
Yep. Basically, it's a little benign tumor that can cause the gland to produce too much PTH.
So it's like having a rogue factory churning out excess hormone.
Exactly. And during surgery, doctors need to know right away whether they've removed the entire adenoma.
Because any bit left behind could keep causing problems.
Precisely. And studies have shown that bioactive assays are really helpful in this situation.
So how do they help?
Well, they show a much faster drop in PTH after the adenoma is removed compared to intact assays.
So it gives the surgeon immediate feedback.
Right. It's like a signal saying, you got it all.
That's amazing. And potentially allows the surgery to wrap up sooner, which is good for the patient.
Definitely. Okay, now let's shift gears a bit and talk about secondary hyperparathyroidism.
Secondary hyperparathyroidism, that sounds a bit more complex.
It is, but it's an important one to understand, especially in people with chronic kidney disease.
Chronic kidney disease, that's where the kidneys aren't filtering waste products properly, right?
Right, and it's actually a very common cause of secondary hyperparathyroidism.
So how are the two connected? What's going on there?
Well, think of your kidneys as filters.
Okay, filters?
And in chronic kidney disease, those filters start to get clogged.
So they can't do their job as well?
Exactly, and as a result, phosphorus starts to build up in the blood.
Phosphorus, that's another important mineral, isn't it?
It is, but too much of it can be a problem.
And how does this tie back to PTH?
Well, high phosphorus levels actually suppress calcium levels in the blood.
Oh, so it's like a double whammy for calcium.
You could say that. And your body, always striving for balance, senses that calcium is low.
And what does it do?
It kicks those parathyroid glands into overdrive, telling them to release more and more PTH.
Ah, so it's like the parathyroid glands are trying to compensate for the problems caused by the kidney disease.
They are, but it's not always a perfect solution.
So in this case, the parathyroid glands themselves aren't necessarily the problem. They're just responding to a distress signal.
Exactly. They're trying to fix the situation.
But sometimes they overcompensate.
That's right, and that's where those PTH fragments come back into play.
Ah, I knew those fragments would make another appearance.
They always do. So for secondary hyperparathyroidism, doctors typically use intact PTH assays.
But we know those assays can also pick up those large fragments.
And those fragments tend to build up in the blood of people with kidney disease
Because their kidneys aren't filtering them out properly.
You got it. So they can actually skew the results of the intact PTH assay, making it look like there's more active PTH than there really is.
So it's like those fragments are creating a false positive.
It's possible, and that can have implications for treatment.
Because if a doctor sees a very high PTH level, they might think the problem is more severe than it actually is.
That's right. They might be more likely to recommend aggressive treatment to lower PTH production.
But if a lot of that PTH is just inactive fragments,
then maybe the treatment doesn't need to be as intense.
That's a really important point. It highlights how those fragments can complicate things.
They really can. And it shows how important it is to consider the whole context when interpreting PTH levels, especially in people with kidney disease.
Absolutely. It's not just about looking at a single number. It's about understanding the bigger picture.
Exactly. Now, there's another condition where those fragments might be playing a role.
Oh, what is it?
It's called pseudo-hypoparathyroidism.
Pseudo-hypo. Say that 3 times fast.
Yeah, I know, right? It's a mouthful. But basically, it's a condition where people have a resistance to PTH.
So their bodies make enough PTH.
They do, but their target organs, like the kidneys and bones, don't respond to it properly.
So it's like the PTH signal is getting lost in translation.
That's a great way to put it. And guess what? Researchers think those PTH fragments might be involved.
I should have known.
They're always up to something. There's some evidence that high levels of those large C-terminal fragments, like PTH 784, could be interfering with the action of the active PTH.
So it's like they're blocking the signal, preventing the message from getting through.
You got it. And that could explain why people with pseudo-hypoparathyroidism don't respond to PTH the way they should.
This is so fascinating. It seems like every time we turn a corner, we find those PTH fragments lurking in the shadows.
They're always there, pulling the strings behind the scenes.
And it just highlights how crucial it is to keep researching these fragments and their effects.
Absolutely. The more we learn about them, the better we can understand how PTH works and how to manage these different conditions.
It could even lead to new treatments, right?
It could. Instead of just focusing on the total amount of PTH, maybe we can develop therapies that target specific fragments.
That's a really exciting prospect. It would be like having a more precise set of tools to fine-tune calcium balance in the body.
Exactly. Now, before we wrap up, there's one more thing I want to mention about PTH testing.
Okay, what is it?
Assay variability.
Assay variability. What does that mean?
Well, basically, there isn't a single universal standard for PTH assays.
So different labs might use slightly different methods.
They do, and that means the results can actually vary from lab to lab, even for the same person.
Wait, so if I get my PTH tested at one lab and then get it retested at another lab, I might get different results.
It's possible.
That's a bit concerning. It seems like it could lead to a lot of confusion.
It could, especially for conditions like chronic kidney disease, where doctors rely on PTH levels to make treatment decisions.
I see what you mean. If someone's PTH level seems to change drastically just because they switched labs, that could lead to unnecessary or even harmful changes in their treatment.
That's right. It's a real concern.
So what can be done about this? Is there a way to standardize PTH testing?
Well, organizations like KDIGO, the Kidney Disease, Improving Global Outcomes Group, are working on it.
KDIGO, okay. What do they recommend?
They advise against using strict PTH targets and instead recommend focusing on trends in PTH levels over time.
So instead of getting fixated on a single number, look at the overall pattern of change.
Exactly. It's like tracking your weight. You don't get too worried about day-to-day fluctuations. You look at the overall trend over time.
That makes a lot of sense. It helps smooth out those natural variations that can occur.
Right. And it allows doctors to focus on the truly meaningful changes in PTH levels.
It seems like we've covered so much ground today, from the basics of PTH to those mysterious fragments and all the ways PTH testing is used in real-world medicine.
We have. It's been quite a journey.
It has, and I'm already looking forward to the next leg of our deep dive. Wow, we've really been through a lot with PTH, from the basics to all those surprising fragments.
We have, and we've seen how those fragments, they're not just leftovers, they could be playing a big role in how PTH works.
It's like realizing those little crumbs at the bottom of the bag, they actually have a lot of flavor.
That's a great way to put it. So let's recap what we've learned about this powerful little hormone.
Okay, where do we even begin?
Well, we started with the basics, right? How PTH is like a master regulator of calcium, constantly working to keep everything balanced.
Right, like a conductor leading an orchestra, making sure all the instruments are in harmony.
And then we talked about how PTH has that incredibly short half-life.
It's in and out of the bloodstream so fast, just a few minutes.
Yeah, it is. So the PTH levels we measure are really just a quick snapshot of what's happening.
And then, of course, we had to dive into those fascinating PTH fragments.
Oh yeah, those fragments.
It's like opening a mystery box and finding a whole new set of puzzle pieces.
And some of those pieces, like PTH 784, they might even have opposite effects on calcium compared to the full PTH molecule.
Mind-blowing, right?
It really is. And it just shows how much more there is to learn about PTH and how it impacts our health.
Absolutely.
Yeah.
We talked about how these PTH assays are used to diagnose different conditions, like primary hyperparathyroidism, where those parathyroid glands are going into overdrive.
Right, pumping out too much PTH.
And we saw how those bioactive assays, they can be really helpful in detecting even subtle cases, especially when the regular intact assay might not catch it.
Yeah, like a super sleuth, zeroing in on the tiniest clues.
And those bioactive assays, they're also really useful during surgery for parathyroid adenomas.
They give surgeons that instant feedback, letting them know if they've removed all the excess tissue.
It's like having a GPS guiding them to the exact spot.
Exactly. And then we explored secondary hyperparathyroidism, which is common in people with chronic kidney disease.
Right, where those parathyroid glands are working overtime to try and balance things out.
Like firefighters trying to put out a blaze.
But even in that situation, those fragments can complicate things, making it harder to interpret those PTH levels.
They can definitely muddy the waters.
It's a good reminder that even our best tests have limitations.
They do, and we need to be mindful of that.
Absolutely. And then there's pseudohypoparathyroidism, where the body just doesn't seem to respond to PTH.
Right, like the cells have put up a wall, blocking the signal.
And guess what? Those fragments might be involved in building that wall.
They might be. And that's why it's so important to keep researching these fragments and their effects.
We need to keep uncovering their secrets.
We do. The more we learn about them, the better we can understand PTH and develop new treatments.
It's like exploring uncharted territory.
It is, and Who knows what amazing discoveries are waiting for us?
Exactly. We also talked about assay variability,
Hmm.
the fact that different labs might get slightly different results for the same person,
Yeah, that's definitely something to be aware of.
especially for conditions like chronic kidney disease, where those PTH levels are so important for guiding treatment.
Right. Any discrepancies could lead to confusion or even inappropriate treatment decisions.
So it's crucial to focus on the trends in PTH levels over time, not just a single number.
Exactly. Look at the bigger picture.
So as we wrap up this deep dive into PTH, what's the main takeaway for our listeners?
Well, I think the biggest thing to remember is that PTH is more complex than it seems at first glance.
It's not just a simple on-off switch. It's a whole network of interactions.
Exactly. And those PTH fragments, they're more than just leftovers.
They're key players in the story.
They are, and as we continue to explore their roles, we might unlock new ways to diagnose and treat a whole range of health conditions.
It's a really exciting time for PTH research.
It is. There's still so much to discover.
That's the beauty of science, isn't it? Always pushing the boundaries of knowledge.
It is, and it's what keeps things interesting.
Well, I want to thank you for joining us on this fascinating journey into the world of parathyroid hormone.
It's been my pleasure.
I hope our listeners learned as much as I did.
Me too.
We've just scratched the surface here, but hopefully we've sparked some curiosity.
And maybe even inspired some future scientists.
That would be amazing. Thanks again for listening, and we'll see you next time for another deep dive into the world of science and medicine.